Hello, welcome to all for the session number 98, which is a special invited session in the honor of Professor C.R. Rao, who is a living legend in statistics, who is completing his centenary next month. And we have a distinguished speakers, Professor David Cox, Professor Bradley Efron, Professor Donald Rubin. And I'm myself, Arni Rao. I'm chairing the session, and I'm a professor at the Medical College of Georgia within the Division of Health Economics and Modeling, and within the Population Health Department. And I'm director of the laboratory for the theory and mathematical modeling in the infectious diseases within the Medical College of Georgia. Professor C.R. Rao, whose name is well known among all the statistics major students across the world, is celebrating his centenary. And I came to know, first time I know his name from my teacher at the high school to undergraduate level, who was a very profound, who had done profound contributions in number theory in the city Vijayanagaram in India. And he was about 4 to 5 years junior in the school in which Professor C.R. Rao was studying. And he was my teacher was a great admirer of Professor Rao, and my teacher himself, his name Professor Peri Sastry, who is currently living in the same city at the age of 95. And he did work on the Fermat's last theorems, and then the other contributions in number theory. And my teacher was a great admirer of Professor Rao since his high school days. But then I was not aware of, I just know the name and his contributions by just name of the contribution, but I don't know any of those things. I don't have any idea of what they are. Until I went to Indian Statistical Institute, I was there, and then my mentor, Professor J.K. Ghosh, late Professor J.K. Ghosh, and through him I came to know, and also Professor Rao's, C.R. Rao's is one of the PhD student, Professor S.B. Rao, he was the director at Indian Statistical Institute. And when I was a faculty, I interacted with them. And when I was a faculty at the Indian Statistical Institute, I used to interact with them. And through them, I came to know about Professor Rao's personality and how pleasing he was, how nice and how obedient he was to as a student, and their days at ISI, all those things. And when I first time met myself, Professor Rao, in the year 2007-2008, when I was a faculty at ISI Kolkata. And he was visiting India touring the India for academic lecture series. And then for last 4 to 5 years, me and Professor Rao, we are jointly editing the Handbook of Statistics published by Elsevier. And we already published 5 volumes together. And Professor Rao has been serving as editor for last almost 3 to 4 decades for the same book series in that's Handbook of Statistics. And I have a great experience of working with him. He's truly a great human being. And then he respects all his colleagues. I met recently last year in 2019 in Buffalo in his residence. And he's extremely in a cheerful mood, and he respects a lot. He respected his elders there, his collaborators. He has he's very sound mind. That's really inspiring for me to work with him and to know him, and we're very happy to wish him a happy birthday and centenary in the centenary year. And my distinguished speakers, I would like to really thank them because Professor Cox, he's about to be, he's within 4 years, he will be a centenarian, and he's not far, but he's been extremely supportive to run the session, because of the virtual JSM is virtual. We all have to do some adjustments, and Professor Cox has been very supportive, and similarly Professor Efron is very supportive, and they're all very excited. In fact, it's not that they're all just invited speakers. They are all Professor Efron, Professor Cox, Professor Donald Rubin. And from there, the way I interacted with them over the last 1 year, Professor Rubin, they're all They are really enjoyed, the moment. They are all excited. It's not, they share a lot of personality, a lot of their experiences of Professor Rao's personality, not only the statistical contributions. They really touched by, you will hear from Professor Cox and Professor Efron's talk, and we all together authored, that is Efron, Amari, Sichin Amari, and Don Rubin, myself, and David Cox. We all co-authored an article we just released in the month of August, a magazine Significance, published by American Statistical Association and the Royal Statistical Society. I'm going to show that the paper details in the very soon, and then I'm going to introduce each speaker just before their talk, and that's what this is about the chair. My remarks on the session, and I would like to take all the questions at the end of the session, and we are also having a written message from Professor Rao after all the talks are done. And once again, I would like to thank JSM2020 and its program chair, Professor David Banks, for for inviting the session, and also Professor C.R. Rao's children, daughter Dr. Tejaswini Rao, who is a retired professor at the University of Buffalo, and his son Mr. Virendra Rao, for providing a lot of photographs for our articles, and then providing a lot of information, and then making the video available, video message of Professor C.R. Rao available. And we all wish him a great happy birthday and continued blessings of God for his health, and successful in his life, further success in his life. And we will now start the session. I will start the slides and introducing the speakers a little bit, and then when each speaker starts the session, I would like to introduce more about the speaker. Yeah, now an overview of this session. I'm extremely honored to chair the session, this invited session, in the honor of Professor C.R. Rao on his centenary. And this session has 3 invited speakers: Professor David Cox, Oxford, UK; Professor Donald Rubin, Harvard, USA; Professor Bradley Efron, Stanford, USA. And all three invited speakers are highly distinguished. They are known to statistics community, including the JSM participants and all the statistics community for their work in statistics. And they all love Professor Rao for what he is, and for his work, for his personality. That's what I understand from their interaction with them. I mean, I know Professor Cox for the last 20 years, since my time in Oxford. But then during last 1 year, I had a lot of interaction with Professor Donald Rubin, Professor Efron, Professor Cox, and then I find they're very excited about this session. And I would like to introduce them just before the talk. And I want to quickly go through a quick overview of Professor Rao in a couple of slides. So Professor Rao was born in India and in 1920, and he completed undergraduate in 1937 from the AVN College, Visakhapatnam. 1940, he was awarded MA Mathematics, Andhra University in India. 1943, he was awarded MA Statistics, Calcutta University. 1945, he published his first paper from Calcutta before he went to do PhD in Cambridge. And this particular paper, with that he became a hero at the age of 25, and which later became a Kramer-Rao bound, Rao distance, and Rao blackwellization. Various methods evolved out of that particular paper. And these all are preserved in this, the articles, but about, the recollections of all the invited speakers in the article titled C.R. Rao's Century. And this article is made freely available to the public by the Wiley, publisher of the magazine Significance. jointly by the Royal Statistical Society and American Statistical Association, just released in the month of August this month. And the participants can make sure make these available for free for all the participants. And then also around Professor Rao's birthday, this article will be available for free. It is written by, jointly authored by Efron, Amari, Rubin, Arni, and Cox. And then I mean, I didn't request the publisher to make, but it's the publisher and the editor, Mr. Brian Torrance, their decision to make it available for free. I want to thank them for that. And Dr. Rao's name appeared in the list of among the other achievements. This is what, according to University of Texas El Paso website, his name appeared in the 57 major contributions from 16th century to 20th century. And Professor Rao's name appeared in among list of 35 major contributions in the probability from 1650 onwards, from the year 1650, according to the University of Southampton website. And he was awarded second highest civilian award in 2001 from India, and that's called Padma Vibhushan. And 2002, National Medal of Science, highest science award in the U.S.A. And 2003, International Mahalanobis Prize. Professor Rao won the International Mahalanobis Prize in 2003. I mean, all the complete details about the awards and all his achievements are there in that in the box in the magazine Significance. And then in the same article, same issue of a magazine, Angel Ricardo Plastino and Angelo Plastino from Argentina, they wrote a brilliant article on in a non-technical way about Kramer-Rao inequality and Rao distance. The participants can look at that article to have a non-technical introduction. And then in the journal Cell Patterns, myself and Stephen Kranz, that also coincidentally released this month, where the techniques of information geometry combining with the conformal mapping techniques of angle preservation, how these combined together can be applied for data science and virtual tourism. That can be seen in the journal Cell Patterns, which is by Cell Press. And I want to thank a big thank to Professor David Banks, Program Chair, JSM2020, for inviting this session and also leading the overall program, which is in a difficult time. We gave a great leadership to smoothly organize the JSM2020 virtual. Thank you. Our first speaker to this session is Professor David Cox. As I mentioned at the beginning, all our distinguished speakers for this session are well known, and every participant in the seminar, in this joint statistical meetings, know their names. But I'm honored to introduce Professor Cox in few slides. Professor Cox and Professor Rao, known to each other for almost 6 to 7 decades. As I mentioned in the beginning, the article which we all co-authored, published in this month of August, issue of Significance, Professor Cox mentioned about his recollections. And currently Professor Cox is honorary fellow at the Nuffield College, University of Oxford. And he is best known for his Cox proportional hazard model and logistic regression model and Cox point process. He has won several awards and recognitions. Some of them I have listed here. They are 2017, Professor Cox has won the International Statistical Prize. 2010, he has won Copley Medal by the Royal Society in the UK. 2005, he has won C.R. Rao and Bhargavi Prize in Statistics. In 1985, knighted by Queen Elizabeth II. 1973, Guy Medal in Gold in the UK. And he has written several books and monographs. Some of them I have listed here. 2016, Keogh and Cox, they written a case control studies. 2006, Cox, Principles of Statistical Inference. 1994, Bardroff Nelson and Cox, Inference and Asymptotics. 1984, Cox and Oakes, Analysis of Survival Data 1980, Cox and Isham point processes. 1974, Cox and Hinckley, theoretical statistics. 1965, Cox and Miller, the theory of stochastic process. 1962, Cox wrote renewal theory, and 1958, Cox wrote his first book, Planning of Experiments. He has been giving leadership to the various societies and academies in the world. Some of them are 1995 to 97. He was president of International Statistical Institute. 1980 to 82, he was president of Royal Statistical Society. And 1979 to 81, he was president of Bernoulli Society. And he was elected a fellow of various societies and academies. Some of them are the Royal Society of London, the Royal Society of Edinburgh, the Institute of Mathematical Statistics, International Statistical Institute, Indian Academy of Science, and the U.S. Academy of Sciences. Now I welcome Professor Cox to deliver his talk.
Yes, okay.
You can take 10 minutes or 15 minutes, slowly.
Yes, okay.
Or as long as you want.
So I'll start in a moment then. You can.
Yes, Professor Cox, please start. Are you ready?
Yep.
Yeah.
Well, it's a great privilege to have the chance of congratulating Professor Rao on this forthcoming centenary. More particularly, of course, it's an opportunity to express my great admiration for his rich, original, influential, and wide-ranging contributions to our subject, which have had such an impact. It would be absurd to aim to summarize these in a short talk, but I make just one brief, more technical comment, that his book, Linear Statistical Inference and Its Applications, I have the second edition, 1973, but there is an earlier edition. That book is a highly original masterpiece of compact and lucid material, in particular, both unifying a great deal that had previously been somewhat fragmentary, but also containing much important new material. For me, it's by far, by a large margin, the most frequently opened and read book that I own. And it has been so for many years and is likely to remain so. I didn't think in these few minutes I'd say anything more about the technical side of Professor Rao's work, but just comment as an an interested but outside observer on Professor Rao's astonishing achievements in India. Mahalanobis, and of course there's a definitive life of Mahalanobis, as there should be of Professor Rao. Mahalanobis had in the 1930s established the Indian Statistical Institute in what was then called Calcutta. This had a major impact both in India, but also in developing Indian-based statistics, which at that time was already vibrant and a major force internationally, including the highly respected journal Sankhya. Mahalanobis had strong and fruitful relations with R.A. Fisher, who visited India several times. Mahalanobis also had bad relations with the few years older Carl Pearson. Mahalanobis sent Professor C.R. Rao, Professor Rao as he is now, to Cambridge to work in Fisher's Department of Genetics. And it's a side issue, but perhaps interesting, that Fisher was in the genetics department a long way physically, perhaps 5 kilometers physically from the statistics department, which was then in mathematics and agriculture. And that was perhaps as well because Fisher had bad personal relations with quite a few people, not on technical, and these were almost all native English or Scots people who'd displeased fish in some way or other. That's a different story. But now at that time, we're talking now about the mid-1940s, I the UK, but even so, I'd heard rumours that there was a brilliant student of with Fisher from India, C.R. Rao, although it was perhaps 15 to 20 years later before I actually met Professor Rao, although, as I say, I'd heard of him considerable time and seen his work and admired his work a long time before that. I had, though, met the formidable figure of Mahalanobis. Now, the first time I visited the ISI in what was still called Calcutta, in the Barrackpore Trunk Road in Calcutta, Mahalanobis was still in command there. And it is perhaps politically interesting that at that time, India refused to take sides in the Cold War between West and East, and the differing responses of the US and the Soviet Union to that reaction, an interesting another story, which I'll not go into. After Mahalanobis' death in 1972, C.R. Rao became the director during what was surely an especially challenging period, politically and otherwise. It saw in part, towards the end, the astonishing achievement of the construction of a fine new centre in New Delhi, of course, hundreds of miles from Calcutta. A wonderful new centre was set up there and formed part of the base of a meeting of the International Statistical Institute. Later, Professor Rao was also strongly associated with developments in Hyderabad, where there is, I think, a street named after him. These massive developments of administrative and organizational kind, combined with research contributions at the very, very highest level, are and were deeply impressive. As I said, I visited ISI several times in this period, and Professor Rao's role in the Institute, administrative and scientific, was deeply impressive. Now, I'm sure, well, I know Professor Rao also made major contributions after he came primarily to the US, but I'm leaving that to others to talk about. I want to conclude with two recollections of Professor Rao that are much more personal, recalled with much warmth. One is of his 70th birthday conference, which was held in Neuchâtel in Switzerland and organized by Professor Yedara Dodge there. And what I recall very vividly is that one evening, Professor Rao's daughter danced with unforgettable style and dignity. I am not an expert. I'm not a dancer myself, and I don't particularly like European style ballet. But this was so full of dignity and emotion. It's something that stuck clearly in my mind ever since. That was the first very personal memory of Professor Rao that I have. The other was in Hyderabad, where for some reason I don't quite recall, Professor Rao asked me to go with my wife and Mrs. Rao, while Mrs. Rao chose a sari. And this proved to be a multiple choice problem of quite astonishingly high dimension. which was not brief. But at a surely judiciously planned moment, Professor Rao himself appeared, made a very brief but characteristically perceptive comment, and all was happily resolved to everyone's satisfaction. And I sometimes think of that little episode as a metaphor for so many of Professor Rao's deeply impressive activities. So, Professor Rao, happy forthcoming birthday, and thank you for your deep and wide-ranging contributions to our subject. Thank you.
Yeah, thank you, Professor Cox. And we will take the questions at the end of all the speakers. At that time, we will take the questions for you, if there are any questions.
Okay.
Thanks a lot for your time in giving a very, very valuable information.
A pleasure. Thank you for all you've done for this.
Yeah, thank you.
Thank
We'll
you.
take questions at the end of the session. We'll take questions at the end of the session, end of all the speakers. Our next invited speaker to the session, Professor Donald B. Rubin. And the title of his talk is "To Celebrate the Centennial of a Remarkable Contributor to the Use of Statistics to Advance Science." And before I welcome Professor Rubin, I'm honored to introduce him through a few slides. Donald Rubin is currently Emeritus Professor of Statistics at Harvard University and also a professor at Tsinghua University in China and a senior research fellow at Temple University. And Professor Rubin is well known for his work on missing data analysis methods, EM algorithm, Rubin causal model, propensity score. And he has won several awards and numerous recognitions. Some of them are in 2017, C.R. Rao and Bhargavi Prize in Statistics, 1995, S.S. Wilkes Memorial Award. He has won 4 honorary doctorates. He was awarded 4 honorary doctorates. They are from Bamberg University, Germany, University of Ljubljana in Slovenia, Uppsala University in Sweden, Northwestern University in the US. He has written several books in statistics. Several of them are very popular. They are Imbens Rubin, titled Causal Inference for Statistics, Social and Biomedical Sciences, and Introduction. 2004, a third edition of his 1995 first released book titled Bayesian Data Analysis, along with Gell-Mann, Carlin, Stern, and Hall. 2019, his third edition book of his 1987 first published book titled Statistical Analysis with Missing Data, along with R.J. Little. And 2004, his classic edition book of his 1987 first published book titled Multiple Imputation for Non-Response in Surveys. He was elected fellow of various societies. Some of them are American Statistical Association, Institute of Mathematical Statistics, International Statistical Institute, American Association for the Advancement of Science, American Academy of Arts and Sciences, and the U.S. National Academy of Sciences. And now I welcome Professor Rubin to give his talk. As I mentioned, all the speakers, they all written a very joint article. We all written a joint article in the month of, which published in the month of August issue of Significance, just released. And Professor Rubin will be speaking more about that article and other issues, other things, other of his recollections. Professor Rubin. Just a minute.
Okay.
Yeah, Professor Rubin.
Okay. Well, I'd like to begin by saying what an honor it is to be asked to celebrate the centennial of C.R. Rao, who's regarded as a remarkable contributor to the use of statistics to advance science in general, and not just a mathematical statistician, although he was and is a remarkable mathematical statistician. And I'd like to especially thank Arni Rao for organizing and inviting me to participate in this session with the other speakers. Okay, next slide. I guess I should make one comment on the first slide. Although I'm best known for being at Harvard for maybe 33, 34 years, I retired from Harvard about a year and a half ago, and actually now I'm a professor at the U.S.A. Mathematical Sciences Center in Beijing, China, and a fellow at Temple University Fox Business School, where I do part-time teaching. Now, my introduction to C.R. Rao was sometime in 1968. I became a PhD student at Harvard about 1965, and I was in a few different departments before I ended up in statistics. And I ended up in statistics after being at Harvard. Basically, right before that, I was in computer science. And in about 1968, I met Bill Cochran, William G. Cochran, who was my PhD advisor. And at the time, because I had already had a thesis sort of underway on match sampling. And Fred Mosteller at the time suggested that I talk to Bill. And at the time, because I'd had a background in physics and math as well as psychology, when I met Bill, I was kind of frustrated by the textbooks that were around at the time, because I found them, I'll say something about this later, too cluttered with sort of irrelevant mathematics. And I said, isn't there a very clean, clear textbook on mathematical statistics without all of these asides, what I regarded as clutter? And he suggested that I look at this new textbook by C.R. Rao. And when I started to read it, I said, finally. It's, you should read, if you wanted to read with clarity, you should read Rao, you shouldn't read Fisher. I mean, Fisher was a genius. I don't think there's any doubt about that, but he was not a very good writer. And I'll make a comment about this later, but I think it's an important point, that in my mind, Fisher was more writing sort of brief notes to himself that he would understand in the future rather than trying to communicate. Next slide. Whereas Rao he wrote with mathematical precision and also with clarity of expression. And because of this, I think that his famous textbook, even though it was written, I believe, in the early 1990s, is still a go-to reference because it is written without clutter. What I mean by clutter are irrelevancies, either in proofs or in conceptual formulations. And I found then, and I still find, much of what was traditionally viewed as mathematical statistics as unappealing because it's replete with that kind of clutter, stuff that is not really necessary. And an example of this is if you stated the Pythagorean theorem by saying, if you have an isosceles triangle, twice the square of the short sides equals the square of the long side. Well, it's not that it's incorrect, but it's bad mathematics. It's bad mathematics because it has an irrelevant condition. And one of the things that makes Rao's writing so clear, and obviously his thinking so clear, is he gets rid of that clutter. And you can see that there really is a great mathematical mind behind the work. Next slide. So one way of saying this is that Rao writing, he wrote to communicate to others rather than to provide notes to himself, as with much of Fisher. Because I found Fisher writing these sort of relatively obscure notes to himself, even in his complicated sentences, or his discussions of the analysis of variance and referencing to the geometry. You find it what Fisher wrote was almost always correct, but it's kind of obscure. And one of the things that I learned from Cochrane, and also from his direction to Rao's classic textbook, Cochrane was a big fan of clear writing. And he also was a big fan of concluding an article with advice to the investigator. I mean, Cochrane would say, you know, who are you writing this article for? I remember the first article that I under Cochrane that I wrote was on matching. And I thought it had lots of clever ideas. I sent it off to Biometrica. No, it was Biometrics. And it got rejected. And by these very long and tedious explanations. And I was really sort of angry. And I talked to Bill, and he said, calm down, calm down. These guys are getting paid nothing to read what you wrote. They're reading to try to, and what they're writing to do is to try to help you write more clearly. These are guys who are your primary audience. The associate editors or the editors didn't pick these guys because they wanted to hurt you. They wanted to help you. So when you write clearly, and always conclude an article on applied statistics, which I was doing back then. Conclude with advice to the investigator, because that's why you're writing this article. You're trying to provide advice. Next slide. So C.R. Rao's work not only was clean this way. Now, I'm not now just talking about his textbook, but his big idea articles, and these ideas bear his name and are relevant now, even in the era of big data, computer science, machine learning, because these are big ideas that transcend sort of the mathematical details of equations. Rao-Blackwell, Fisher-Rao information, Rao distance, Cramér-Rao bounds. All these are big ideas, and they're attached not only to Rao's name, but often to some other people's names, people who are obviously great, like Fisher, Blackwell, wonderful, wonderful guy. Cramér I never met, so only these guys who were attached besides Rao who I ever met was David Blackwell. Wonderful, wonderful man. Next slide. And so and this focus on big ideas, these were communicated with mathematical precision and without the irrelevant clutter, which I find abounds in mathematical statistics, less now than in past days. In past days were the early days of a field of statistics. And so I think the mathematicians who did a lot of the writing didn't know what the big ideas really were. And so there was a lot of sort of what I would call now thrashing around, trying to dig through to figure out what the big ideas were. Rao, because of his mathematical background, sort of saw these big ideas without having to thrash around very much, which many of the statisticians did. Next slide. Another thing about C.R. Rao that was not surprising, really, but maybe surprising for the era. He remained incredibly modest about his own work and accomplishments, and also incredibly supportive of younger people's work, including when dealing with and helping younger and less talented colleagues. And I remember Cochrane mentioning this, how impressed he was with Rao's modesty and supportive nature. And one other thing is, I never heard, despite Fisher being doing battle with people like Neyman and John Tukey all the time. Their stories are renowned for how Fisher would love to do battle with these people. But I never heard Rao say anything negative about anyone. In fact, in conversations we talked about other people, he'd always had something good to say about people, and especially having an advisor like Fisher. I guess it demonstrates not only his basic good nature, but probably his good upbringing in India with a proper regard for your elders and other things. But he's just a wonderfully supportive person. Next slide. And I recall several meetings, conferences in my early years where he arranged to have me invited. And I regarded that as kind of especially encouraging. It really was encouraging to me, because at the time I was doing sort of unusual work. I was sort of Bayesian. I wasn't very traditionalist because of my background with Art Dempster at Harvard. And I was doing applied things. I was doing this match sampling, which has become more popular in the last decade in economics. But back then it was, nobody was in hardcore statistics was doing match sampling. This idea you should get rid of bias in design and not rely completely on models to get rid of the bias. So that was what I regard as unusual work for the time. And also I had a non-standard primary affiliation. After I graduated Harvard with my PhD, I spent 1 year sort of as a postdoc, or as actually I think it was called a lecturer at Harvard, and then I went to Educational Testing Service, ETS, where the focus was primarily on quite applied problems in psychometrics. And although I had also a visiting part-time lectureship at Princeton University, which is there at the time was chaired by John Tukey, the primary job was Educational Testing Service, but it was not a very then at least prestigious place statistically. It was prestigious in psychometrics, but it wasn't prestigious otherwise. Next slide, please. C.R. Rao was also the heart of statistical programs. And of course, he was the heart of statistical programs in India, where he was regarded early on as a great man, partially because of his PhD at Cambridge under Ari Fisher. But early on in the United States, especially at Penn State University, where he spent most of his career until he retired. And I don't have the exact date when C.R. retired from Penn State. But also, he not only was a supporter of statistics at Penn State, where he was a distinguished professor. I don't remember the name of the title right now. I apologize for that. But also in support of other departments. What I mean by that is he also gave up his time to be on visiting committees. That's what VC stands there. I mean, there were a couple of visiting committees at Harvard University where the departments and the Faculty of Arts and Sciences at Harvard every 6 years or 8 years had a visiting committees that were composed of very distinguished people from outside, like CR, like Janet Norwood, who's a commissioner of labor statistics in the Secretary of Labor, the Department of Labor in the U.S. government. And he would give his time and his very soft-spoken, again, advice on what kind of programs we should have, and he was very sympathetic with the need to teach, as well as attract distinguished other faculty. So he was a wonderful supporter of other departments. Next slide. He was respected and admired by widely respected and admired by older statistical stars. I'll just give a couple of examples from personal discussions, because I knew both these guys, John Tukey and Jerzy Neyman, fairly well personally. I knew Tukey well as an undergraduate, and then I would, after I graduated, I would work at Educational Testing Service, where John was a consultant. And even as a graduate student, I wrote programs for John. And I remember a couple times when I rode with him to Bell Labs, where they're writing programs on permuted title indices and using COBOL. What is it, COBOL? Some other list processing language. And then I got to know Jerzy Neyman fairly well in the mid-late 1970s when I visited Berkeley. I guess I had a Guggenheim or something like that. And the visitors had offices upstairs, I think on the top floor of Evans Hall, which is where the retired faculty also had offices. And so I got to know Naaman fairly well. Wonderful experience talking to Naaman. But I remember one thing very, very clearly. Although CR's advisor, Fisher, had fights, and the fights with Naaman are well documented. But there are arguments with John Tukey as well that are documented in Joan Fisher Box's biography, where Tukey went storming out of the garden after talking to Fisher about something. And Tukey, at some time in his life, was trying to make Fisher's arguments about fiducial work better, and Tukey was working at it. Tremendous admiration for Fisher. But both these guys made comments to me what a fabulous addition CR would have been to any department, and of course their departments as well. And of course, at the time when Tukey was chair, there was a wonderfully strong department, and in some ways is trying to return to that these days. And Naaman was although he fought with Fisher for years, was a tremendous fan of C.R. Rao's. Next slide, please. The most memorable comment, personal comment that I ever heard, this just sticks in my mind, has stuck for many years, was from Bill Cochran in 1968, when C.R. Rao was only highly admired. I think he was a younger man in 68 than he is now. It was quite a few years ago. But because Bill Cochran had spent many times visiting India, he used this expression, which reminded me recently of the sort of the corny Hollywood movie, Jewel of the Nile. And he used this expression that he will become, or surely become, a jewel of statistics. And I remember that expression, a jewel of statistics. I think it probably was at the time a relatively common phraseology in India to describe a precious person. And boy, Rao surely did. So see our happy upcoming birthday. It's a real honor to be able to join in the celebration. And I think that's the end. Yes.
Yeah, thanks a lot. Thank you very much. You want to adjust your camera, Professor?
Sure. Yeah. It's better. Okay.
Thanks a lot for a very wonderful and detailed account of Professor Rao's career and his personal life. And it's amazing, you recollect all those things from the 60s and your teachers, your own advisors. Yeah. And I would like
I think it's a very sort of wonderful era when people could easily separate personal disagreements from contributions of the other guys. So Fisher and Naaman obviously had many heated battles, but they both respected each other's work. And then you take someone like C.R. Rao, he obviously respected all of their works as well, and could see the strengths in each of their perspectives. And again, I never heard C.R. say a nasty phrase about anybody. He was just a wonderfully warm and generous person. And I assume he still is.
Yes, he still is, yeah. And then we will having Professor Rao's message after all the talks, and we will take the questions from the participants, and then that will be after all the talks and the message is over. And I will come back to you for questions again.
Thank you very much, Arni. And thank you again for inviting me to participate in this wonderful event.
Yeah, I look forward for the question and answers.
Bye-bye.
Thank you. Our next invited speaker to the session is Professor Bradley Efron, and the title of his talk, 100 Years of Geometry in honor of C.R. Rao's Centenary. Before I welcome Professor Efron, I'm honored to introduce him through few slides. Currently, broadly, Efron is a professor of statistics and biomedical data science at Stanford University. And he is best known for his technique of bootstrap and information geometry methods, which he will be speaking soon today. And his recollections, he has been associated with Professor Rao for several decades, and they have been known to each other for several decades. And he has won several awards and numerous recognitions. Some of them are in 2019, he has won International Statistical Prize. And 2014, Professor Efron has won Guy Medal in Gold in UK. And 2005, the US National Medal of Science. And 2003, C.R. Rao and Bhargavi Prize in Statistics. 1990, S.S. Wilkes Memorial Award. And several popular statistical books are authored by him. Some of them are 2016, Efron and Hasty book titled Computer Age Statistical Inference, Algorithms, Evidence, and Data Science. 2010, Efron book titled Large Scale Inference, Empirical Base Methods for Estimation, Testing, and Prediction. 1993, Efron and Tipshirani wrote Introduction to the Bootstrap. 1982, Efron, The Jackknife, The Bootstrap, and the Other Resampling Plans. And he has been serving several societies in the leadership roles and mentoring roles. Some of them are in 2004, he was the president of American Statistical Association. In 1987 to 88, he was president of Institute of Mathematical Statistics. And he was elected a fellow of several societies and academies in the world. Some of them are the American Statistical Association, Institute of Mathematical Statistics, International Statistical Institute, American Association for the Advancement of Science, American Academy of Arts and Sciences, U.S. National Academy of Sciences. Now I welcome Professor Efron to deliver his talk. Professor Efron. Yes. Yes, please start.
Okay. Thank you, Arni, and thanks also to Tija. This is a nice time. We're here, at least virtually here, to celebrate C.R. Rao on his 100th birthday. 1920 was a wonderful year. It was the end of the flu pandemic, and it was the birth of C.R. Rao in India, I believe somewhere near Madras. And CR, if you have any more of those pandemic ending powers, this would be the time to use them. Wikipedia says that C.R. Rao is on everyone's list of top 5 post-war statisticians, and he's certainly on mine. And he played a big role in my own statistical education. I'm going to say more about that soon. So for that reason and others, I'm really happy to be here today. I wish here was really here, but this is the best we can do. Next. Next. Yeah. Excuse me. Let's start in about 1965. I'm a new postdoc at Stanford, and it turns out I actually made a list of top 5 statisticians at that time. Of course, I was the new guy, I didn't know much, but I did know who was pretty good. And my own top 5 list included Herb Robbins, Charles Stein, John Tukey, David Cox, and of course, C.R. Rao. And if my Stanford education had been a little broader, I probably would have included Jimmy Savage, Spacey and Jimmy Savage's also. And Robbins and Stein, both hard-edge decision theory, name and est frequentists, but they both got dragged into the Bayes world through empirical Bayes. Tukey, John Tukey, as far as I can tell, didn't pay much attention to any statistical philosophy. He worked more in the wonderful tradition of applied mathematics. David Cox, here today, here in quotes again, works in the great tradition of British statistics, maybe 50% frequentist and 50% Fisherian. But that leaves Professor Rao, who is by anybody's count the leading Fisherian of the post-war period, starting on even before his 1948 PhD under Fisher at King's College. And to say that Rao is a Fisherian doesn't get across the fact that he's really was Fisherian, really was Fisher's student in the sense of carrying on Fisher's tradition of insightful geometric intuition. Next. 1945 was an amazing year for the 25-year-old Rao. 3 landmark achievements, the Cramer-Rao lower bound, the Rao-Blackwell theorem, and the Fisher-Rao metric. And none of these hyphenated ones were direct collaborations, rather simultaneous brilliancies spanning 3 continents. Of course, 1940s had been the war, and communication was not very good across the world. In Rao's hands, the Cramer-Rao bound is an example of Pythagoras' theorem carried out in a probability space. The Fisher-Rao metric concerns distances between probability distributions in a Riemannian manifold using the Fisher information matrix to define local distance measures at each point in the space. And so how did the 25-year-old Rao get to that? Well, Mahalanobis had asked him how one could assess distances between clusters of different castes and tribes, verifying the point that great statistical theorists are also great applied statisticians. Next. So we're in 1965 again, with me as a new postdoc at Stanford. And one day, Professor Rao's book, Linear Statistical Inference and Its Applications, arrived, a book Professor Cox rightly described as magisterial. It was a big day for me. Stanford's PhD program at that time was completely frequentist in a hard-edged decision theoretic form, done masterfully by people like Stein and Chernoff, Olkin, and Parson. But over in the med school, Lincoln Moses, Rupert Miller, and Bill Brown ran a biostatistics consulting program that was much looser and more Fisherian. They could do almost anything using maximum likelihood and t-tests. In Sequoia Hall at that point, maximum likelihood was hardly heard of because it's hard to analyze carefully as the hard-edged world like. And Rao's book was an eye-opener for me and for other people, showing the depth and power of the maximum likelihood estimate and other Fisherian data analytic methods. Next. So a few words about Fisher and the MLE, dating from 1925. We'll get back to Professor Rao very soon. In a paper that set the stage for about half of the 20th century statistics, Fisher in 1925 introduced information and efficiency and showed that maximum likelihood estimation was efficient. And so let me state that a little more carefully. We observe independent observations, x1, x2, xn, from some density f sub theta of x. We want to estimate theta with some estimate theta hat, some function of the data, t of x1 through xn. And Fisher's definition, he didn't actually call it this at this time. I think the terminology may actually be Rao's, that T is first order efficient if it asymptotically achieves the Fisher information bound there in the pink. which says essentially that the variance of theta hat is 1 over n times the information in one Fisher information in any one observation. And Fisher, of course, was trying to show that MLE was the best thing ever. And it turned out, that older estimation methods like minimum chi-squared, a Pearsonian technique, was also first order efficient. So that didn't prove that MLE was best. Next. So Fisher kept working in by 1934, he showed that the MLE is a sufficient statistic in one parameter exponential families and multi-parameter exponential families too. And in general, that the MLE loses less information than competitors. That is that the limit of the information in the full sample minus the information in a one-dimensional statistic theta hat is the information in one observation times some constant C. We'll see that constant again. And Fisher said, and C has its minimum possible value for the MLE. So it's better than minimum chi-squared. And if you look at the Fisher's work between 25 and 34, you'll see a certain mystic quality about the proof, first of all, and secondly, what the result, even if true, means in terms of, say, squared error estimation. Next, please. Next. Oh, sorry, go back. Okay, next, please. So we're back to Fisher, to Professor Rao, 1961-62. Another great couple of years for Rao. Two seminal papers, 1961, Fourth Berkeley Symposium, Asymptotic and Limiting Information, 1962, JRSSB, Efficient Estimation and Optimal Inference in Large Samples. And these papers, in very clear, elegant mathematical terms, showed that in multi-parameter families to second order, the MLE is the best one-dimensional estimate of the true score function. That is, it supported Fisher's claim and in an undeniable way in terms of the information. And he coined the term second order efficiency for this property. And the 62 paper was followed, as it is in England, by a lively discussion. Professor Rao was there in England, in London, giving the talk. And the discussion is full of praise for the paper's bold development, and but was not completely uncritical about the conclusion. Herman Chernoff, for instance, said that the Rao information result didn't clinch the case that the MLE, for instance, was best in terms of squared error estimation. Next. So here I get into the picture. In 1975, I joined the argument with a paper in the Annals of Statistics entitled Defining the Curvature of a Statistical Problem with Applications to Second Order Efficiency. And again, this is a discussion paper. The discussants span the philosophical spectrum, including, besides Professor Rao and Professor Cox, Lacombe, Lindley, and many others. And what I showed was what Chernoff was concerned about in terms of squared error estimation, that the MLE is superior to all other first order estimates in terms of a squared error loss. And I called this the Fisher-Rao theorem in honor of Fisher and Rao, because it really was just frosting on their cake. And incidentally, the curvature in the title turned out to be that information loss constant C in Fisher's 1934 work. And I should say that to say that the MLE is best in this case uh, uh, you have to be careful about the bias. It's not just the variance. Bias, by the time you try and be careful to the second order, uh, uh, the bias turns out to be, which is of smaller order than the variance, turns out to be important. The curvature in my title relates to the Fisher-Rao metric for distance between two members of an exponential family. And reading the previous work, my own paper was I tried to write it very much in the same geometrically wise form that both Fisher and Rao were masters of and are masters of. Next. Well, it's easy to think that maximum likelihood was destined to rule the world, but that isn't necessarily the case. We're in 1980 now, and Joseph Berkson was a distinguished biostatistician from the Mayo Clinic, a good theoretician too, and a longtime critic of maximum likelihood. And this can be seen in the title of his 1980 paper, Minimum Chi-Squared Not Maximum Likelihood, with an exclamation point at the end. There aren't too many Annals of Statistics paper with an exclamation point in the title. And yeah, I'm quoting there in the next line from the abstract. The sovereignty of the MLE is questioned. Second order efficiency is rejected as a criterion of goodness of an estimate. And he gives, Berkson gave an interesting logistic regression example where minimum chi-squared has smaller variance than the MLE. And in this paper, this time Professor Rao and I and others were discussants, and I was able to point out that the MLE won again if you took bias into the correctly into the. So well, it's 40 years later now, and the MLE is more sovereign than ever. Now often with some kind of regularization thrown in for high dimensional problems. It's the go-to method in our journals, including those in the machine learning world. And the MLE is the ultimate Fisherian device. And I believe Professor Rao has played a central role in its acceptance in the math stat world. Next, please. So here's our last slide. It's 2020 now, and I really wish that we could have had this session in together at a real JSM instead of a virtual one. But the COVID-19 has intervened. It's made Professor Rao a two-pandemic man. I really wish it hadn't happened, but if we could pretend it hasn't, and I can imagine an enormous birthday cake being rolled out at the end of the session with 100 candles on it and one to grow on, plus a chorus of hundreds to sing the birthday song, and I'd have joined in very happily. But that can't be. Instead, let me just thank CR for a really inspirational career and wish him happy centenary. Thank you.
Yeah, thanks a lot for the wonderful talk, Professor Efron, and a very nice birthday song. And I welcome all the questions. This is followed by Professor Rao's video message, virtual message to all the speakers, and then followed by the question and answers. Thank you.
Maybe you should. Oh, this is Donna.
Thank you for making this easy to do. I appreciate it.
Yeah, you can start.
Oh, Teja, I very much enjoyed being in the movie last year that you came out to. And thank you so much for being supportive of
Professor Rao, and say hello to Professor Rao personally for me right now. That's it.
I want to express my gratitude to the joint statistical meetings and the program chair, Professor David Banks, for including a session to celebrate my birth centenary year. I am very happy to note that my long-time colleagues and eminent statisticians, Professor David Cox, Professor Brad Efron, and Professor Donald Rubin, are presenting at this session. I want to express my thanks to them and to Professor Arni, who is chairing the session, for their very warm birthday wishes. I am also deeply touched by their articles in the journal Significance. My best wishes to them and to all participants of the meeting. A heartfelt thanks to you.